Ready to complete the bread and potions exercise with Elixir's protocols? This video shows you how to define and implement the edible protocol, simplifying how different items affect your game character's stats. Let's dive in and write some flexible, polymorphic code. Grab your starter file and follow along. Howdy, I'm Kevin. In these videos, I combine my years of development experience with AI tools to help present comprehensive and idiomatic exercism solutions. I prompt Copilot to add documentation and provide starting solution. We'll critique its output and explain why it works or doesn't, and refactor into clean idiomatic Elixir together. I'll include content from NotebookLM for solid introductions like the upcoming introduction to the Elixir protocol.
Imagine a game. How does a single eat command work for bread, potions, and even poison? The answer is Protocols, Elixir's tool for polymorphism. It lets behavior change based on the data type. We'll see how Protocols let you write clean, maintainable code and say goodbye to complex conditional logic. First up, we define the edible protocol. It's the official rulebook for any item you can consume. The protocol defines an eat function. It specifies the inputs, but not the actual logic. That's next.
Copilot's implementation of the protocol, edible, is spot on. It's nice there's a documentation clause about what this does, but the main star here is this abstract function header, def, so defining a function, eat, has two attributes. This is similar to what you would do if you had multiple function heads and you needed to provide a default value. You could additionally include a specification for this function to say the item being eaten could be of any type, but that the second argument had to be of type character, and that the return value would be a byproduct, which could be anything at all or nil, and that the second tuple element had to be also a character.
Time to make our loaf of bread edible. We'll implement the protocol to give it a specific action. This implementation gives the character 5 health points and returns nil, meaning there's nothing left over.
Let's break down the syntax about implementing the edible protocol for the loaf of bread. So we're defining an implementation of the edible protocol for the module loaf of bread. And inside of this block, we would expect to implement all of the functions defined in the edible protocol. We simply have one, which is eat. So here we're saying def eat. The item we're eating has to match the structure loaf of bread as the first argument. The second argument has to be the character, and then we have our eat function. Now we're also taking advantage of pattern matching by saying we know that when the character eats a loaf of bread, we need to change their health. So we're pattern matching and grabbing the health in the signature of the function. What we're supposed to return is a tuple. The first value is a byproduct. When you eat a loaf of bread, there is no byproduct, so it's nil. The second is the updated character. We can use the update syntax for maps where we take the character and we augment it with a new health, which is the current health, plus 5.
Protocols allow any user to implement new behavior for existing types, making your core system closed to modification, but open to extension.
Now for mana potions. The challenge here is returning a byproduct, the empty bottle, after use. This implementation restores the character's mana and correctly returns that empty bottle just as required.
Eating a mana potion, drinking a mana potion is very similar. We are defining for the edible protocol, for the mana potion module, when we eat one, we pattern match a mana potion's strength, the character's mana, we return the artifact of an empty bottle, and we update our character. Their mana should be the existing mana plus the strength of the mana potion. You can specify a visual style for the video overviews in NotebookLM. I think the anime style worked really well for this exercise. Do you have a favorite AI learning tool I should try? Tell me about it in the comments.
Finally, let's make poison edible. This will prove how flexible protocols are, even with harmful outcomes. The poison uses the same eat function, but look at the outcome. Health drops to 0.
Let's compare the implementation for poison to that from the mana potion. We're going to pattern match poison, struct, instead of the mana potion, of course. Poisons don't have a strength, so we don't need to pattern match that bit out. We have the character, We don't need to pattern match anything about the character because we're not increasing their mana or adjusting their health. We're simply setting the health. So we simply are saying, hey, this eat function takes a poison struct for the first argument, the character struct for the second argument, and we need to return the byproduct of an empty bottle and the character with its health set to 0.
Did you know Elixir's core data structures all implement the enumerable protocol, enabling the entire Enum module to work seamlessly across lists, maps, and streams?
Where these implementations of a protocol live is largely dependent on the project you're working on and the overall structure. Often you'll find them in the same file as the edible protocol is defined like this. This would sort of indicate that edible is a separate concept and that the core things like loaf of bread and mana potions are core to the application. You might also see them like this, where we take the module about poison, which defines its structure, and we define the edible implementation here. This would indicate that edible is more of a core concept and that poison is more of an outer or changeable.
These examples clearly show the power of Elixir protocols. One interface, many different behaviors. This is what idiomatic Elixir is all about, separating the data from what that data does. The takeaways are huge. You achieved polymorphism, decoupled data, and wrote clean code without messy conditionals.
If this video helped you eat that exorcism challenge, give us a like. It's the best way to return the health points. Don't let your learning protocol lapse. Hit subscribe so you never miss a new video implementation. Explore the playlist to build your Elixir expertise, one powerful function at a time. See you there.